To be honest, developers don't really care about resilience, reliability, or even security until there was a bad event.
This is DevOps Paradox, episode number 188. Foster a culture of resilience with Steadybit. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, in this world of chaos, only one thing is true.
Me.
Yes, it is you that is true.
Okay, I did not expect confirmation of that silliness, but thank you.
Okay, you're quite welcome. But when we think about chaos, we like chaos theory. Butterfly flaps its wings. There's a hurricane that happens or a tsunami that happens. But in our world, we have this concept of chaos engineering, and we've talked about chaos engineering over these past few years. But today we have on with us Benjamin Wilms from Steadybit. Benjamin, how are you doing?
I'm good, and thanks for being part of this great podcast.
We're going to talk about chaos engineering today. And it's been a while since we have. We wanted to bring Benjamin on to sort of talk about what he's seeing, but I want to take him back to the past. Benjamin was an author of the open source project that was Chaos Monkey for Spring Boot. Now, for all you kids out there that don't know what Chaos Monkey is, Netflix open sourced it in 2011. So hopefully you were born before 2011, but just in case you're listening to this, parents, thank you for letting your kids listen to us. Benjamin, why don't you take a moment and talk about what made you want to get into Chaos number one, and beyond that, why did you want to create a wrapper around Chaos Monkey, especially with Spring Boot?
Because I'm a developer. And normally, if you talk about chaos engineering or Chaos Monkey, you will inject chaos on different levels. But I'm as a developer, I'm more focused on my application, my service. That's something I will develop. And my biggest motivation is to get this new service, maybe new feature for the service, into production as fast as possible. I learned it the hard way, that production is not a happy place to be. It's not like to spend hours with your family in production because it's such a nice place. No, it isn't. Production hates you. And that's something I have learned quite hard. And so I would like to be more prepared, because normally what you're doing in software development and software testing, you're just testing the happy parts. But I'm a big believer that you should also take care about the unhappy parts. So I would like to combine, let's say, a load test with bad behavior injected. I was looking for a solution. Chaos Monkey for Netflix and other open source tools are able to do it on levels like cloud provider, container, Kubernetes, and all the stuff. But as a developer, I'm more focused on my service, my application. And that's where I would like to inject bad behavior during my test cases, during my integration tests. And that's why I created Chaos Monkey for Spring Boot, because at this point, I was then able to inject bad behavior in my test cases, in my dev cycle.
So back then, where were you doing chaos? Production or pre-production? I want to see the level of braveness.
Don't start in production. Of course, if you take a look at the principles of chaos engineering, if you take a look at all the books that are written by very famous people, you should do it also in production, but don't start in production. Why? Please be more proactive. Please take care to shift left all those testing approaches with chaos engineering in the early beginning of your software development process, and not like in production, because there are already a lot of incidents in production. There is already a lot of chaos in production. So why should I inject more chaos? Let's do it earlier. Let's do it before production.
I completely agree on that. We should always practice whatever we're doing. I don't think that this is even related with chaos, right? We practice before we go to production. Your hello world is not going to run in production first, and then everything that follows. But production the final goal? Because, I always have that conflict with any type of testing that doesn't have to be chaos, but could be performance testing, right? Load testing, integration testing, that until you reach production, it's almost impossible for us to actually reproduce production conditions, right? Hence, impossible to test it properly, fully, without eventually, 3 years later, reaching production. I don't know whether you share the same view or...
Kind of a different view. And of course, you are not able to clone production. You're sometimes are not allowed to clone all the data. Maybe there are some very sensitive data in production. You are not able to clone or mirror into a different environment. And also it's getting very expensive if you need to provide a different production environment. So it's something you're not able to do. But you can start small. You can start on specific services to improve them. You can increase the radius later on to test and verify if a group of services is able. You don't need a full copy of production to train yourself, to improve yourself. For example, I would like to see, before my customers are affected, if our monitoring is able to see an outage or latency increase in a couple of seconds or milliseconds even. And not like, okay, put it in production, fingers crossed. Okay, customer's calling us, he's not able to use our platform. That's not a good metric. You need to train yourself. You need to train your whole organization to be prepared. And that's something you can start earlier in pre-production staging environments.
Who should be doing chaos testing? Is it something that can be shifted left towards application developers, or we need certain level of expertise for that?
To be honest, developers don't really care about resilience, reliability, or even security until there was a bad event, until there was an incident in production and the data from our customers is gone, or maybe until we have been hit by a big AWS zone outage, region outage, whatever. But now we are in the point like, okay, our customers are affected. We have lost customer revenue, and even worse, we have lost customer trust, and that's something you are not getting back very fast. And that's something, if you have lost it once, it's very hard to get on the same level back. Yeah, that's hard.
You're so kind. I usually answer to that question is until they receive the call 3 o'clock in the morning instead of somebody else to fix it.
No, but you also ask about shifting left. Yes, please do it. And that's something I was able to see at our customers. So it's like, how are people rolling out chaos engineering? There's an expert group from the SRE departments. There is sometimes a dedicated chaos engineering team. Why? Because those people are sitting in front of production. They are able to see how production is working, how production is getting into bad conditions. And that's very big experience. That's a lot of knowledge. And now they need to find a way how to enable, by shifting left, their developer teams. Okay, please take care about, there was an incident. This incident, that's something we would not like to get back into the same situation again and again. Please prepare yourself. Please take care about the next features, because it's always like this battle between new features, feature velocity, or how big should the risk be in our system we are taking to get in production. It's like handle the risk.
As an engineering manager or as a developer, how do we sit down and prepare for that risk? What is my strategy in defensive programming, I guess?
A good point is to take a look at the last incidences. You have hopefully done maybe a post-mortem analysis, so you can get a clear picture about where you are good at, what you can do is good and what not. That's a starting point. And then you are able to get, let's say, to describe your expectations. For example, is your expectation we need to survive in zone outage by our cloud provider? Do we need to survive node outage from our Kubernetes cluster? That's something you can just decide. Is this a risk we should handle upfront, or are we just taking the risk? And then you can prepare yourself. Then you can create a test case. What does it mean? Let's test it upfront before production. Are we able to survive latency in a specific area of our services? With that in mind, you are able to improve your system. Or maybe, okay, let's take the risk, but you are aware of this risk.
What if someone in the organization says, we don't have time to do this extra testing. We've just got to get these things shipped. What's the case against that?
Let me start by sharing a story from one of our customers. There is this SRE team, and they have told their management 3 years again and again, we should roll out chaos engineering into our organization. But there was not a commitment by the management. They have told them, no time, no budget. Please continue the SRE activities. And this SRE group was hunted by production. They was hunted by incident and incident again. And they were not able to spend time to improve the system proactively. And then there were 2 big major incidents with a very big revenue loss. This time the management was coming back to the team. Okay, you told me 3 years ago we should do it. Let's start right now. It's a bad approach. It's not something you should do. It's more like, okay, learn from that and please be aware of that. That's something you are not able to maybe survive like this customer has.
Well, your answer there is, as programmers, as engineers, we have to speak the language of the business person. And at the end of the day, that language is money.
It's customer trust and revenue. Yeah. You need to get your mind into more business case related argumentation. That's something where people from upper levels are able to understand. You have to find a way how you can present the risk in a non-technical way. If you go to your management, okay, AWS zone outage, what is this zone? I have no idea. Or maybe you were not able to do a rolling update. What does it mean? You have to present something. You have to prepare for that moment. And that's something you can just do with chaos engineering. You can tell them and show them that's the risk I'm talking about. And that's the impact if we are running into this situation.
I believe also have a issue with maturity, right? I believe that organizations need to have certain level of maturity with something in order to go down the route with chaos engineering, right? If somebody is moving right now to cloud, probably chaos engineering is not the first thing that they're going to think of, even though they should, just to clarify. Or, hey, I just discovered Docker, and next year I'm going to work with Kubernetes. So there is also, I believe, that level of order of things, maybe, not the level.
But that's a very high risk you are taking. So for example, you go to your cloud provider and you are using, let's say, a managed Kubernetes. You are still in the situation that so many things on different levels can go wrong. It's not under your control. And that's something you have to know up front. So if you are moving to the cloud, your problems are getting bigger and not easier to handle. And it's something, you have to start early and not like, okay, let's move to the cloud first and fingers crossed we go to production the first time. Oh, that worked not quite well. No, that's not something you would like to be.
So you're saying going to the cloud, how would you do chaos in a self-managed way? I'm thinking on-prem or private data centers. Cloud is simple, right? Because we have all the tooling around that to where we can easily do that. Like Chaos Monkey 10 plus years ago gave us the ability to do that easily in AWS.
Can I correct you for a second?
Sure.
I don't think that it's about tooling. And correct me afterwards, Benjamin. I think it's about APIs, right? Can you, on-prem, can you access and do everything through an API? If you can, then in theory at least, you can do all sorts of things, including invoke that API to simulate outage.
I agree on it's not a tooling problem. If you're not the expert and you are creating a new system, you need to learn and see how your system is reacting. You need to see how your system is living. And that's something where you have to work with a running system. And tooling is easy. It's getting complicated if you're at a specific scale. If you need to do it in a safe way. For example, if you are an organization with 100 developers or 5,000 developers that are different levels. So if you are starting with chaos engineering and everyone should do chaos engineering in your organization and you're not taking care about some safe ways or some regulations or maybe some role-based access control to not run into a situation that teams are killing each other. So for example, they are all running experiments and they are all checking their system. You need to do it in a controlled way, in a safe environment. And that's something you can organize by yourself by just finding time slots. Then you are allowed to do it this way. Or maybe you can pick up a tool or a platform to do it in a safe and easy way. But the point is, if you are not able to answer the question, where should I start in my system with chaos engineering and how? That's the biggest blocking moment. It's like, okay, you need to be an expert for so many different topics in your daily doing. And now someone is telling you, and you should also do chaos engineering on top of all. That's like, okay, that's too much for me. You need to provide an easy entry and in small steps.
So what I'm hearing from both of you is if I do not have APIs to my infrastructure, because typically chaos starts with infrastructure, or am I wrong again? What do you think?
It really depends on your role. So if you're in a DevOps team, or maybe you're in the SRE, you are more on the platform level, like Kubernetes or maybe cloud provider level, or even deeper on just infrastructure level. But you're not able to get your teammates from other areas like product engineering teams to understand, okay, what is the impact? If you are killing your infrastructure, what is the impact? Because I'm just maintaining a service and I don't know how the service has been running in our big platform. Is it based on Kubernetes? Is Kubernetes based on a managed cloud provider version? Are we doing it by our own? How are our virtual machines scheduled? Is there an auto-scaling event? So there are so many different levels. It really depends on the role where you are starting.
So there is chaos within the chaos without even writing one line of code.
If you're doing it wrong, yes. So that's why you need to start smart.
The subtext that I've heard from the things that you've said, if it was SRE team, if it's a DevOps team, and I'm needing APIs in order to do this testing, this is one of the great questions that people ask us a lot, is as a DevOps person, as an SRE, should I know how to code? And if you're going to be doing chaos, the obvious answer seems yes. Is there a way to do chaos in 2022 and beyond unless you know how to code?
Can I do a little advertisement? Yes, you can do it with Steadybit. Let me describe a little bit more in detail. So what does it mean, code? Is it that you need to develop software, that you write your own source code? Or is it what you are referring to describe it in a way like you are describing your infrastructure as code? It's like you have a standard, and this standard is code, of course, but you don't need developer skills. Let's describe your cloud environment with Terraform, for example, or you have some Ansible playbooks. Is this what you are referring to, or is it to be a developer?
I would define actually coding as creating something that can be interpreted by machines. That's my definition of coding, right? It can be interpreted by machines. Like, hey, if you write a Word document, my server does not know what to do with it. If you write Go code, my server does something with it. If you write YAML, still the same logic, right? Now we can talk about different level of understanding required for YAML versus Go and this like that. But to me, both are coding. Both are creating artifacts interpretable by machines.
Okay, then I agree on that. And the answer is yes, you have to be able to write code. You have to do chaos engineering to improve your system proactively. You need to get into a position that you can automate stuff, because you are not able to spend hours and hours every month to do it by hand. It's something where you're doing it once, executing it by hand, and then you would like to automate, because you need to get into the position that you are able to do it in a regression testing approach. So you would like to, let's say, replay a specific incident. You can code it. You can use platforms to execute such code. And then you would like to test continuously if you are still able to survive the described conditions in your code.
And something you just said there, being able to replay a specific incident.
Mm-hmm.
When we've talked about chaos engineering in the past, it's usually sort of the front side of chaos engineering, right? Because when you're first getting into it, you're figuring out, okay, what kind of test do I want to do? Do I want to kill off compute? Do I want to disconnect database? Do I want to make the network unstable? But this concept of replaying specific incidents. So it's Black Friday, and all of a sudden we've got a rush to a specific page because we've got the best deal in the region on this one item. You don't think about that as being chaos, but it is, because nobody expected that the Tickle Me Elmo was going to be the greatest selling thing of all time. How would you capture that information as it's going so you can make it replayable in the future?
How to receive or retrieve those informations to be able to replay this?
Right. So how do I, in the heat of the moment, so I have a real life scenario going on right now. how do I capture that correctly? Because I could capture back and replay back web logs, right? That's been around for decades. That's not a big deal. But that's only part of the problem. I mean, it's probably a big part of the problem, but it's not the whole problem. So how do we capture sort of a snapshot in time of, okay, what is this chaos? And it's not just a snapshot in time, unfortunately, with chaos. It's a window of time that you have to capture.
Exactly. It's a window of time. And what our customers are doing is they are doing, so in the point of an incident, you have no time to spend endless hours to improve your system and to learn from it. It's like you need to record everything you need later on to take a look at. So what they are doing is they have very good monitoring solutions where they are able to get these time snapshots later on in the postmortem analysis. They are taking care about logging. They are storing logging. They are describing what they need to log to be able to understand what's happening or what has happened in the postmortem analysis. And that's the starting point where they are now describing, okay, there is a stream of events in a specific time window. Let's pick up the streams. Let's pick up like, okay, it was in the beginning, it was like DNS was not working in a limited space of our network. That was the root cause. Let's call it or frame it a root cause. And then after a couple of minutes, there was a CPU spike. There was a resource overusage by specific services. And then the latency is increasing. And that are events in a specific order in time they would like to replay. It's not that they are taking care about why it's happening. It's more like, okay, this is an event that can happen. Let's pick up the specific order to replay it, to prove if we're running the same situation, if we are able to survive or not. It's not about why this is happening. It's more like, be prepared.
You mentioned monitoring, things like that. Does that mean that chaos tooling is complementing or in a way using other tooling, right? I imagine that I would be designing some experiments, I would be running some experiments, but if not fully, then at least partly I would actually evaluate the results of experiments through my standard, let's say, monitoring solutions, right? It's not that I'm using chaos experiments tooling alone, right?
No. Then you are blind. You're not able to see what's going on in my system. There's nothing where you are creating value or data for you that you are able to answer the question if this chaos experiment test was successful or not. So it's something you have in mind. You need to be aware of, okay, what are the metrics we have to take care of? When is our system healthy and when not? That's something you have to be very clear in answering. And that's also like the big evolution I can see with chaos engineering. Chaos engineering is more like getting into the position of an engine, something you are using under the hood to inject bad behavior with the possibilities chaos engineering is providing. But then you need integrations. So that's why you need a very good orchestration platform that is able to start experiments, to consume data from your monitoring solutions, from your logging systems, from your load tests, and to get everything in one place so that you are able to get a clear picture about this execution time window. What's happening in my system?
Nice, because I've seen cases of people taking very simplistic approach to chaos engineering in terms of, hey, let me design an experiment that if I destroy this replica of my application is still responding. I do that in a very unit testing type of way and never realize that actually there is something seemingly unrelated, broken in the system, right?
Exactly. I'm describing it in a way that people are normally getting started with like, there's a big toolbox with a lot of attacks inside. And like, let's pick up one attack. Let's call it the hammer attack. So they are picking up the hammer out of the toolbox and they are using the hammer to hit their own system. But what they are doing is just they are verifying the attack and not how the system is reacting. It's like, okay, attack hammer is working. Yeah, wow, big learning. No, it isn't. You need to see how your system, how your organization is reacting under a hammer attack.
Well, the hammer attack for most people is, and you sort of talked about it earlier, DNS is always the problem, by the way, in case you didn't know that.
Network in general.
So when people are writing their chaos experiments, how many of them actually just always throw in DNS? Probably a low number. And if DNS is dead, nothing works.
Yeah, there are some caches involved. So a specific time you are able to survive, but
You're assuming that the
And
caches
then
are working correctly.
you are so exactly, and you are not able to see, okay, what is the time to be alive, or what is the time to be listed in the cache until it's trying to get a new refresh. So it's something you should know.
This leads me into my next point is, again, we were joking about DNS, but not really. But if we were actually running load tests and DNS failed and the cache is timed out and your load test was still running, but yet every time you'd run it before, there was no problems, but you had never specifically tested the DNS failures, then what's going on with the load testing? And then really, typically when we talk about chaos engineering, we don't talk about load test in the same breath.
Yes, but you need to. Because why? I would like to shift it left. And what's missing? Traffic. Traffic in systems on the left is not there. You need to create a load test. You need to execute a load test. What our customers are doing is like they're executing the load test once without any bad behavior injected by a Steadybit platform. And the second run is then by injected with some chaos experiments. So it's like they would like to see the difference. If everything is fine, load test successful. But now let's inject latency. Now let's inject a DNS outage. What's going on in the system? Are we still able to see the performance we need? And are we still able to respond in a good quality for our customers? That's something they have to answer.
But then again, we're going back to what we were talking about earlier. Is this good for my customer? And if that's not the first question you're trying to answer, then why are you even doing chaos engineering to begin with?
It is good for your customers because you would like to prove upfront if your system is responding in good quality and under good performance, even under bad conditions. Because I, as a customer, I don't care if AWS is going down or your Kubernetes cluster has been not running. I would like to consume your service. I would like to buy products on your webpage, for example. It's not my fault that you are not able to survive under bad conditions. If so, I will go to the next one. I will go to your competitor. I will buy something which I need right now in this moment from one of the competitors. So that's something you have to be in mind. It's like customers are, if you are providing an app on your smartphone, you will be deleted if you're not able to deliver even under bad conditions. So it's something you need to be prepared for.
And that's the point I was trying to make is usually as programmers, we're not always thinking about the customer. We're just trying to think about what's in my IDE, what's my commit count I have to get in today, what's all the other stuff I've got to do. And if I even happen to think about the customer, again, that kind of stuff isn't taught in school. And unless you have been the one having to write the paychecks, you're not thinking typically about customers.
Yeah, it's too far away from your daily doing. It's not in your daily doing.
That's why I asked that question at the very beginning, who should be doing chaos engineering, right? Because what you're describing, Darin, I see it as a result of too big of a separation between teams and responsibilities to the level that nobody knows who is responsible for something, right? Kind of. So this is not working. It's testers. It's operators. It's developers. It's whomever is not you, right? And if you have that type of separation, then you cannot have a clear responsibility, right? Because if it could be anybody, but then why would it be me?
Someone else is doing it. No, you need to know whose job is it. It's a team sport. So you need the experts from the SRE department. You need the experts who are sitting in front of production. With all this knowledge in their minds, you are able to get started as a developer. I need to know what's going on in production. But normally developers are like not so close to production because of the pipeline. Everything is automated. They are just, release a new feature and it's done automatically. But what does it mean to be in production?
I think sadly, the team sport analogy falls apart. I mean, by sadly meaning, we would think under the umbrella of a company, we would be one team. But in reality, we're actually a league and we're teams playing against each other.
Yeah. And the teams are not on the same size. So for example, the SREs are one example of our customers is like 30 people. But on the other side, there are 5,000 developers pushing into production with new features. So it's a very unfair ratio between those two teams.
You've been sort of alluding to the customers now. Again, you're the CEO at Steadybit. What was the problem that you saw or that you were going through that made you decide, the Steadybit thing sounds like a pretty good idea?
It's very strong connected with my open source project you mentioned in the beginning. It was the Chaos Monkey for Spring Boot applications. So I did it by my own because I would like to solve a problem in my daily doing. And then I decided, let's put it on GitHub. Let's see if there is something out there and other people are facing the same problem. And this was being picked up by people around the world overnight. It was like, I'm not alone. There's more to do. And that was like this initial moment, this big momentum for me. Okay, you can do something. Let's create a product, Steadybit, to help people in the same area as I'm working right now as a developer. And I build it, I run it. So it's like there are more people like me. Let's try out if there's something we can build to solve the same problems for other people.
If you've been listening along and then you go out and look at the Steadybit site, which is at steadybit.com, a lot of these items that we talked about today, load testing, being able to replay attacks, are all sort of baked into Steadybit. Most other chaos engineering tools that we've looked at, or solutions, depending on how you want to look at it, cover just one little piece of things. But it appears that Steadybit sort of has this whole umbrella of replay and load test and sort of the whole package. Was that the initial part for Steadybit, or was it's evolved over time and you kept on adding these things on in a very intentional manner?
It's because we were very focused on our product and we are searching for feedback from customers and users in the very early. So we founded Steadybit and we built a just chaos engineering platform where you are just focusing on attacks. But then we learned from our customers and design partners, that's not something we can use. We need more. We need more integrations. We would like to see how we can interact with our load tests during the execution of an experiment. We would like to see the data from our monitoring solutions because there is already the single point of truth in our monitoring APM solutions. Let's reuse this data. And also like the integration in the other way, like you should send out markers to your monitoring solution so that we are able to see when Steadybit is executing something, starting, stopping, creating attacks and so on. It's like this movement where we are actual in this orchestration platform. So Steadybit is interacting with many different tools. So we have integrations into load testing tools, K6, JMeter, Gatling. We have integrations into Postman, integrations into monitoring solutions, Datadog, Prometheus, Instana, and so on. And all because our customers have requested. That's how we need to do it in the daily doing. That's how we can roll it out. Also, the next evolutionary step was to attack something, to discover something, is more getting into a commodity feature. It's like, people would like to create something by their own. That's why we have now extensions in the product where people can create their own attacks, their own discovery components. It's open source and people would like to contribute. And it's like that we are moving more and more into the platform level, orchestration level.
When you speak with your customers, again, we've talked about, we were poking on the customer is the most important thing here. When you were working with your customers or your design partners at the time, when you think back on that, what was the one thing that somebody asked you for that you thought, I would have never thought of that?
Multiple events. It's like one big aha moment very early in the beginning was like, don't start with the attack first. Let's describe our expectations. Let's create a feature where we can describe our expectations on our system or describe the capabilities our system needs to have in a repeatable way and in a way that I can share it with my teammates. That was a big aha moment. It's like not just picking up the hammer from the toolbox. It's more like you need to be able to do a rolling update under load. You need to be able to survive outages, partial outages in your system. That was one of the elements. Another big element or moment was, it was a nice conversation with a very large customer, and he told us, okay, you're doing it with an agent-based approach, Benjamin. With Steadybit, we need to install agents to do something. We are running at scale. At scale does mean we are running 30,000 EC2 instances on AWS. I would like to install an agent on every single instance. Provide something else. And then we are able to create a connection to the cloud AWS account. So they can now do it at API level, just by an API call in a safe way with the help of Steadybit. That was one of the elements. And the last one I would like to mention is every system of a customer is a tiny snowflake. They are using all Kubernetes, or most of them are using Kubernetes. Some of them are using Azure, Google Cloud, AWS. But still, there are so many different parts that are not under control of Steadybit. So they would like to continue and would like to create their own experiments, their own discovery components. They would like to discover specific parts of their system we as Steadybit are not able to do. And then we realized that created an extension kit. And now they can do it in their own preferred language, in Python, Go, whatever. They can just interact with Steadybit on API level.
So if people wanted to learn more about Steadybit, obviously they can go out to steadybit.com. What should they expect when they get there? I mean, what should they be ready to do?
It's a very easy entry. You don't have to do very big steps to get started with Steadybit. And something which is very important for us as all founders, so totally as 3 founders, we decided people need to get their hands into the product as fast as possible. I personally don't like to talk first to sales before I can try out the product. So it's like, get started with Steadybit for free. They can sign up on the website, play around with the full product, because that's the center. That's the center for us as Steadybit. It's the product. The product needs to deliver value for you. And that's something you should receive in a couple of minutes and not like after 1 hour of sales call.
So if people wanted to get in touch with you, what's the best way to do that?
On Twitter, if you are still on Twitter, by mail, LinkedIn, or even just sign up for on our contact form on our website, request a demo. So there are multiple ways.
So all of Benjamin's contact information is going to be down in the show notes. Benjamin, thanks for being with us today.
I enjoyed it very much, and thanks for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.